Hello everyone. In this video I wanted to go over a couple of power problems where the information wouldn't be so straightforward. Would have to manipulate a few things first before you could actually find what the answer is. So the first problem is, what is the average power output of a weightlifter who can lift 250 kilograms, 2 meters, in 2 seconds? Well, we know that power is equal to work divided by time. And we know that work is force times displacement. So we can substitute that in. So force times displacement divided by time. However, I didn't give you the time either. Or, pardon me, I didn't give you the force. So we have mg, that is the force, that's the weight of this object. Remember, weight and force, same, multiplied by the displacement. And all of that divided by the time will give you the power. Well, we do have the mass, that's 250 kilograms, multiplied by 9.8 meters per second. I'm assuming that the weightlifter is on Earth. And they lifted a vertical displacement of 2 meters, and that gets divided by 2 seconds. So the power output is 2,450 watts. So I guess the trick is that we have to make sure that we convert the mass to a force. The next problem, a 1,000 kilogram car accelerates from rest to 25 meters per second in 7.5 seconds. What is the average power output of the car? So we write down the equation for power. Power is work divided by time, and then we've got force multiplied by a displacement divided by time. The only thing that you're told here that looks even remotely close to something we can use is seconds. So we need to be able to figure out what the force is and also figure out what the displacement is. And this is going to require us to go back into using Newton's laws and also some of the kinematic equations. We'll use Newton's second law to find the force, and we'll use one of the kinematic equations to find the displacement that it undergoes. So in solving for the force and the displacement, here's Newton's second law, the mass of the object multiplied by the acceleration. And we have a 1,000 kilogram object, and it's going from 0 to 25 meters per second. So I've just the change in the velocity is 25 meters per second is really what I'm saying here. And that gets divided by 7.5 seconds. So the force is 3,330 newtons. Here we have the displacement is equal to 1/2 the acceleration multiplied by the time squared. Now keep in mind that this is a truncated version of one of the kinematic equations I gave to you earlier in the year. And I didn't include the initial velocity multiplied by the time in this equation because I know that the initial velocity is 0. So we can plug in the values for the acceleration, which we got from Newton's second law over here, and that's 3.33 meters per second, multiplied by 7.5 seconds squared, and don't forget the 1/2, and we get a displacement of 93.7 meters. So when we put all this together, if we take the force of the 3,330 newtons and multiply it by the displacement, the 93.7 meters, and we divide that by the time, what we end up with is a power output of 41,600 watts. So this problem's a little bit trickier in that the only thing that we got in the equation initially was the time, and you were given a couple of other pieces of information which didn't seem to fit, and we needed to solve for those using some prior information that we had gotten from previous lessons, the force and the displacement. Anyway, I hope you found this useful. Thanks for watching.